There's the soliton. There's the standing wave. That one happens to be 600 feet in diameter. It's still a smoke ring, big cigar. You know what I'm saying?
I guess.
Our guys put together the math and sent them to Tom Banchoff at the University of Illinois, and he and his guys ran the algorithms on it. The data that comes out of our model, by definition, creates a torus, and that's what a high-density charge cluster is. Electrons burst in Avogadro's number off the end of a probe at a high voltage, organize themselves. Instead of just dissipating and going away from each other, they organize themselves into a torus, which is a stable configuration. It is a standing wave. It's a soliton. And we find them ubiquitously throughout nature. There's the vortex that results from that soliton when it goes into a further expression. There's the same archetypal shape. It's exactly the same shape, exactly the same dynamic, exactly the same rules, just at a different scale. This one that was before it is Hurricane Katrina. Well, didn't we see that before? Haven't we seen that shape before?
Oh, the galaxies.
Have you ever heard of a phallico-soliton? You want to have some fun? Take a frisbee into a swimming pool sometime. Let the water get nice and smooth. Spin the frisbee around 3 or 4 times, then pick it up out of the water and stand still. 3 times out of 5, you do it right, another vortex will appear somewhere else on the surface. And if you have an eyedropper with a drop of ink in it, if you drop it in one, it'll go right down under the water and come up in the other one. They self-organize. Complementarity is part of the function. It's all about these very basic fundamental rules. And it works all the time, and it works everywhere. Look, the Earth and the Moon are a standing wave by definition. And so are the other planets in the solar system. And guess what? If you look at the distribution of mass in our solar system as a function of Fibonacci relationships, in terms of how far the relative masses should be spread from each other, we are 0.00043% shy of a perfect Fibonacci distribution all the way out to Pluto. And it's only because of the irregularity of Pluto's orbit that we have a variation. And Pluto's not a planet, so.
What's it doing?
But you know, that's got to say something to you. It's got to say something to you. And so here we are, and you look at this wonderful thing called Hoag's object. This is galaxies. This is stars, but this is a ring of galaxies around this galaxy. These are galaxies each. Galaxies each. Tell me that's not a standing wave. It is. The Sombrero Galaxy, same function, looking at it end on. It's ubiquitous in the cosmos. And at the center of it, here's how the law of thermodynamics really works. At the physical vacuum, there is always fundamental balance. The physical vacuum is always in balance, everywhere. At every locale, there's always imbalance. Because everything's in motion. It's vectored in one direction or another. And it is that imbalance, as a function of the organization, that creates the fractal record that shows us where we've been. That's the way it works. The way the universe stays in balance is that at the same time that it is organizing these tornadoes, it's unorganizing them in a way called black holes. What black holes do is just unwind everything the tornadoes created. Same dynamic, exactly the same. And we know they're for real, and we know what they look like because we got pictures of them, thanks to Hubble. Look at that. I mean, you've got galaxies colliding, you've got black holes eating them. There's an extraordinary photograph of a black hole eating a star, disaggregating it. And what happens is that it takes all that information, all the stuff that came up from the physical vacuum, up to all those scales, you put it inside the maw of that black hole, and its function is to create such pressure, to create such velocities, to exert such extraordinary force that it literally disaggregates it and redeposits the undifferentiated potential back into the physical vacuum.
Continuous creation.
There's no such thing as a Big Bang.
David, why don't you discuss a little bit on the nuclear stuff?
I will. Okay, so we've got a whole bunch of other stuff here. We've got three technologies. I'm just going to tell you what they are. I'm not going to spend any time explaining because I know everybody's going right straight to sleep. And I'm sorry it's so
Along
late.
with you, right?
I'm sorry it's so late. Nova Institute of Technology is a privately owned research organization. We've affiliated with other organizations. We have partnerships. We have a little company called Nuclear Remediation Technologies, Inc. Dick Shamp is here with us. He's the president of that company. And for nearly 15 years now, Dick and I have been working together to take the laboratory data that we created with Dr. Jin, who was the top plasma physicist in the People's Republic of China until he escaped from Mao's hard labor camp. Now in the United States, now got his green card, did seminal work proving that Ken Scholer's high-density charge clusters can effectively be used to remediate radioactivity and gamma in liquid solutions of 40% molal solutions of thorium in distilled water. We have the data. We did it for 7 years. We've been trying to figure out how to put the pieces together so we can take this technology to the street. And we're hoping within the next few weeks that we'll be able to consummate a set of negotiations that we've been working on for a long time now. But all of the technologies that we're using in that regard, all of the dynamics that we're relying on are taken right out of this model. Everything about high-density charge clusters, about relative velocities, about electron densities, about all of that stuff that we can use to change the fundamental atomic behaviors of radioactive materials comes out of this model. It's all validated, and we're pretty excited about being able to do it. We're hoping within 3 to 5 years to have alpha units that we can go on site with so that nuclear power plants can literally treat their fuel waste as it's coming out of the pile. They ought to be able, based on our numbers, to get 8 or 9 times as much useful energy out of the residue as they did out of the original fuel rods, just because of the way the technology works. So it's a pretty exciting project, and I want to welcome Dick. He's been working on it and putting up with us till midnight. So
does that have potential for Yucca Mountain?
It would obviate the necessity for Yucca Mountain altogether. The Department of Energy knows all about it. Spencer Abraham's watchdog, Frank Goldner, called us on the phone, screamed at us, told us to quit sending the information. They didn't want to hear it. Didn't want to hear it. They're going to put that stuff under Yucca Mountain. And the reason there's so much institutional resistance to solving the problem here is that there's so much money being made exploiting it. I mean, the glassine encapsulation industry is a $12 billion undertaking. And that doesn't count all the other stuff that's going on down there. And
They've
so
got 60 to 80 billion set aside for Yucca Mountain.
So we've been doing what we can to solve the problem. We have a technology that really works. It's not the only one for sure, but we know this one works because we've had our hands on it. And even with our Rube Goldberg benchtop devices, bubblegum and baling wire and spark generators, we made it happen. So we know that stuff works, and we're hopeful we're going to get it into the marketplace. 2 other things we've done that are worth talking about. We've designed a self-recharging electric vehicle that's based on a technology that uses a proprietary rotary engine with the new 502 Freon gas.